Welcome back to WizNose. We're traveling through the solar system. We've explored the Sun, Mercury, Venus and the Earth. Now we're up to Mars. Mars is the fourth planet from the Sun and is the last of the terrestrial or rocky planets. First discovered from Galileo Galilei, it is visible in the sky and known as the red planet because of its reddish-brown coloured surface. It has weather patterns with clouds and an atmosphere, and even has ice caps on its north and south poles. Just like Earth, Mars has a core with iron and nickel, which is like Mercury, Venus and Earth, but it also has the addition of 50% sulfur. Very similar to other terrestrial planets, it's got a rocky mantle and a crust made of iron, magnesium, aluminium, calcium and potassium, like what you find in bananas. The rich iron oxide particles in the soil are what gives the planet its rusty red colour. It's time for a data dump. It's pretty obvious today. I'm actually going to choose red. The diameter of Mars is 6,794 kilometers or 4,219 miles. The average temperature of Mars, well, now going to the chilly temperatures, minus 63 degrees Celsius or minus 81 degrees Fahrenheit. The average distance from the Sun is 227,940,000 kilometers or 141,550 miles or 1.52 AU. The rotational period of Mars is just over a day, 24 hours and 37 minutes. The orbital period of Mars is 686.98 Earth days, almost twice as long as Earth's year. Well, not quite, 1.88. Mars has an elliptical orbit, which means that it gets colder and hotter depending on its distance from the Sun. Mars has two moons, Phobos and Deimos. Phobos, which measures 22 kilometers or 14 miles, is closer to a planet than any other moon in the solar system, with only 6,000 kilometers away. Its orbit around Mars only takes 7 hours and 40 minutes. It's predicted by scientists that in about 50 million years that Phobos will likely crash into Mars, and as it grinds its way around the planet, it will break up and likely turn into rings. Mars's axial tilt is 25.2 degrees. This is also very similar to Earth, meaning that the northern and southern hemispheres, the seasons last for under 6 months because of its length of its year. Just the same as on Earth, when the northern hemisphere is tilted towards the Sun, it is summer, and Mars reaches a temperature of 27 degrees Celsius or 81 degrees Fahrenheit. Then, as it's tilted away from the Sun, it becomes winter and reaches the very chilly temperatures of around minus 133 degrees Celsius or minus 207 degrees Fahrenheit. It's also because of this tilt that the poles receive minimal sunlight. Actually, about 3.5 billion years ago, Earth and Mars were more similar than they are today, as Mars also had water on the surface and also had a much stronger protective magnetosphere, making the exploration for evidence of ancient life on Mars a very considerable question. Mars has a very thin atmosphere, mostly composed of gases, carbon dioxide, nitrogen, and argon. It has other very small amounts of gases and even a tiny amount of water vapor. The surface pressure on Mars is less than here on Earth at 0.64, and so is the gravitational force, meaning that if you weigh 25 kilos on Earth, you'd only weigh 9.5 kilos on Mars. Since we've been tracking who the craters are named after so far, I think we'll keep on the tradition. Craters that are greater than 60 kilometers on Mars are named after scientists and astronomers, and there's a few really big hitters on this list. Get it? So we have Christian Huygens, Giovanni Cassini, Isaac Newton, John and William Herschel, and Nicolaus Copernicus, just to name a few. Mars is home to the tallest mountain in the solar system. Have you heard of it? It's called Olympus Mons. It's a massive 27 kilometers or 17 miles high. That's about thrice of the size of Mount Everest. It's called a shield mountain and was formed differently than a lot of mountain ranges on Earth. They're mostly formed around the faults of the tectonic plates. We learned about that in my Earth episode, so if you haven't watched it, watch that one next. Olympus Mons is a gigantic volcano, roughly the size of the state of Arizona in the United States, and was formed by lava flowing out and setting over millions of years. Not only Mars home to the tallest mountain, but you could also find the biggest canyon there, right near the equator, in a region known as the fastest bulge in the western hemisphere of Mars. It's called Valles Marineris and was named after the spacecraft that discovered it. In the 1970s, the Mariner 9. It stretches over 4,000 kilometers or 2,500 miles long, which is 1/5 the way around the entire planet, and is about the same size of the whole of Australia. It is over 200 kilometers wide and is a massive 7 kilometers or 23,000 feet or 4 miles deep. Scientists think it was most likely formed by a rift fault or essentially a big crack in the planet's crust and made bigger over time by erosion and the walls collapsing in. It's similar to how the East African rift here on Earth was formed. It's possible at some point there was water flowing there, and scientists are now exploring the possibility of water ice beneath its surface. Now we're going to talk about the missions to Mars.
As it turns out, Mars is kind of a tricky planet to land on, even though you're probably pretty aware of rovers on Mars and can possibly even name one or two. We've come to know lots about the planet from these super machines driving around on the surface of Mars, but this wasn't always the case. Almost half all the missions to Mars have been a failure, meaning they crashed into the planet too fast or didn't even make it that far. From 1960 to 1964, there were 6 failed missions, with the first 2 not even making it out of Earth's orbit. Following that, launching in 1964, NASA's Mariner 4 made a successful flyby in July 1965. NASA then had a few more successful flyby missions, while the Soviet Union had several more failed attempts, with some real bungles like booster timers set incorrectly and failed communication systems. The 1970s saw some victories for the Soviets with their numerical Mars missions 1 through 7 having mostly or partial successful orbits and flybys. It was during this decade that NASA's Viking 1 mission made the great feat of successfully deploying a lander. Shortly after this, the Viking 2 mission also made a safe and successful landing to the planet's surface and remained operational for the next 5 years. Woohoo! The 80s and 90s saw more failures than successes, with Japan and Russia now launching their own unsuccessful missions or not, since the Mars 96 crafts never left low Earth orbit and became yet another failure to launch mission to Mars. Moving on to the 2000s until present day, and we have some more successful missions than failures. I guess we do learn from our mistakes. Scientists and engineers learned that for a successful Martian landing, several things need to be precisely calculated to survive what's known as the 7 minutes of terror. There are two main problems that were turned years of hard work, engineering, and expensive equipment into nothing more than space junk. Firstly, the distance from Earth to Mars can make things tricky. The craft must be able to land independently, without instruction from the control center on Earth. This is because of the lag or delay message communications because, well, Mars is just pretty far away from us. The other problem is that the thin atmosphere means things can enter too fast and end up with a crash landing or be burned up during their descent, and kind of like a meteorite burns up on its way through the Earth's atmosphere. Right now, in 2024, there are 6 active orbiters: the Mars Odyssey, the Mars Express, Mars Reconnaissance Orbiter, Maven the Trace Gas Orbiter, the Hope Mars mission, and the Timeline 1 Orbiter. There's also rovers Curiosity and Perseverance, or Percy, and the first of its kind, an adorable helicopter named Ingenuity, or Jenny for short, marking the first aerodynamic flight on another planet, which recently completed its mission on January 25th this year. If you want to see more about the Mars rovers and how NASA Jet Propulsion Lab has learned to master the 7 minutes of terror, I'll add a link in the description to one of our family's all-time favorite engineers called YouTuber Mark Rober, who famously worked on the Curiosity rover, which along with its pal Percy, is driving around the surface of Mars, investigating geology, climate, and environmental conditions in a hope that one day human exploration will be possible on Mars.
There's so much more to learn about the red planet, but I hope this has given you a bit of an idea. It's one of our planets in the solar system that gives us hope of human missions to another planet in the future. As usual, like, share, and definitely subscribe to my channel. Over and out. Actually, haha.